All right, so slope. Slope is given to a line to describe how steep it is. So when we look at a line that's very, very steep or very, very flat, we can't just describe it with words. So we're going to give it a number. And it's kind of like a rating on how steep a line is. And that rating is what we call a slope. So if you see a line that's very, very steep, I can say, wow, that looks like it has a slope of 10. But you need to know what that means and what it looks like. So today we're going to look into how do you give a line a number that tells us how steep it is. And it's the ratio of the vertical change to the horizontal change. So it's kind of like describing a staircase, right? You can look at a staircase and say, wow, that's very easy to climb, or whoa, those steps are very difficult to climb. And depending on how the steps look, if the steps are really tall and short, it might be difficult. But if the steps are really wide and long, then it makes it easier. So we're going to look at that, those type of dimensions, how tall and how wide from one point to the other. So slope is given a letter, and that letter is M. It's believed that M comes from the word mountain, which is a slanted side of a hill, or because it's slanted on a mountain, we can think of that as being slope. So every time I see the M, I think of mountain, and it makes sense because mountains are slanted on the side. Sometimes you'll see the words rise over run, which just identifies the vertical value and the horizontal value, the changes in Y. And the change in X. So when you're given the line, we're going to just find the slope. Let's do two of them. And all I mean is I want to know how slanted is that line. And you're going to give me the rating in numerical form for the slantedness or the slope of the line. So let's say I have a line that goes from here to here. And I'm asking you, how slanted is that? You can say, it's kind of vertical, kind of going to the right in the northeast direction, but more specifically, we give it a value. And I like to just use the arrows because it tells me what I'm looking for. And I want to know how tall and how wide. So I'm going to use red, and I'm looking from this point to this point. And I only need one triangle. I can create more triangles on the line, but all you need is to identify one step, which would be this one here. And I see that it's 1, 2, 3. And this is 1, 2. So if I'm here and I want to get to here, I'm going to go to the right 2. That's my bottom number. And my denominator. And then I'm going to go up 3. That's my numerator. So my vertical distance is 3. My horizontal distance is 2. Let's do another one. Say I have this one here. 1 point up, 1, 2, 3, 4 points to the right. And I want to know how slanted this one is. Not only do we say that how slanted it is, but we also give the direction. This one's going uphill, so it makes sense that it's a positive slope. This one I notice is going downhill, so I'm expecting it to be a negative slope. And it's a little flatter than the other one, not so vertical, but that doesn't matter because we're going to give it a number that identifies how slanted it is specifically. So let's see, we have a vertical and a horizontal value. And my vertical value to go from here to here or here to here. Let's go from the top to bottom this time. Down 1 So I'm making it negative because I'm going down. And then 1, 2, 3, 4 to the right. That means positive. And so my slope is negative 1/4. All right, so let's keep note of things. If you're going up or to the right, you're going to make sure your numbers are positive. If you're going down or to the left, then your number value is negative. So in this case, you're going positive, positive. That's why my two numbers were positive. And in this one, I was going down, which is a negative direction, and then positive, which is why I got a negative fraction there. So that's what you do to find the slope between 2 points given a graph. Now, when you want to find the slope between 2 points and you don't have a graph, you use something that's called the slope formula. And the slope formula looks like this. It's going to be your vertical values divided by the change in your horizontal values. And it's going to be, your vertical values come from either y coordinates. Your horizontal values come from your x coordinates. And then that's going to give you your final answer. So let's look at an example of this specifically. Say I have the point, let's say 1, 2. And then I have the point -1, -3. And I want to know how slanted the line is between those 2 points. I don't want to use the counting method. I want to use the formula. So what I'm doing is I'm trying to find how tall that step would be and how wide. But notice, we're not going to always have a graph. So we have to have a strategy that's going to allow us to get those same values without having a graph. And if you notice, all you're going to do is look at from 2 on the y coordinate, you went all the way down to -3. How far did you go from 2 all the way down to -3? So all you needed to look at was this number here and this number here, which is why I wrote them up here. So all you're going to do is take this y coordinate of 2, subtract it from this y coordinate of -3, and you end up adding the opposite and you get 5. So see how that works? From here to here, the whole distance was 5, but I didn't need the graph. All I needed to know was that this number subtracted by this number will give me 5. And now I want to know the horizontal distance. The horizontal distance means I'm going to be looking at my y coordinates. So to look at your y coordinates, those are -1 and 1. So this would be my first point, second point. So I'm going to start with 1 and then -1. Now if I ask you, how far is it from -1 to +1? From -1 here to +1. That's this x coordinate to this x coordinate. That distance is 2. And then mathematically over here, you add the opposite and you still get 2. So that's how the slope formula works. It allows us to use the coordinates to find the vertical number, and it allows us to use our x coordinates to find our horizontal value without having a graph. Okay, so let me show you how that works with just an example. Find the slope. Between -6 and -1, 9. Now, to do this, I'm going to do what I call the skeleton. And I say skeleton because I used to teach this in October, and it's the structure of the formula without the numbers or without the meat. And the meat would be the numbers that I'm plugging in. Now, I do remember that slope is always going to be the vertical values on top divided by the change of the horizontal values on the bottom. So I would need my y coordinates on the bottom, on the top, and my x coordinates on the bottom. So it's always best to label which one's your first point, which one's your second point. Those are my x and y from my first point, and my x and y from my second point. I know that on the top, on the numerator, I'm going to need to put in my y coordinates. So -6, I'll start with my first point, and 9. And then in the denominator, I'm putting my x coordinates. I need to know the horizontal distance between the points. So that's 2, again, starting on your first point, and -1. It's important to label which one's your first point because you don't want to go first point, second point, and then go second point back to the first point. Got to be consistent. So if you start on this first point, always start on that first point. -6, adding the opposite gives me -15. -6 and -9 is -15. And then you add the opposite again, and that gives me 3. So my total slope was -5. And there you go. All right, so what happens when you don't have a slanted line? You might have a horizontal line, or you might have a vertical line. And if it's horizontal, and say you want to go from this point to this point, you notice that when you're trying to find your slope, you don't have a vertical value. You can't go up or down, so that's going to be 0. But you do have a horizontal number, so it's just going to be some value. And when you have 0 divided by any number, your answer is going to be 0 slope. However, when you have a vertical line, say you want to go from this point to this point, and the distance right now doesn't matter. You want to find your slope like we've been doing in the past. And you will need to move a vertical distance, so you will have a number there. But you do not need to go horizontally in any direction, so you're going to have a 0 value there. And then when you have a number divided by 0, mathematically you cannot calculate that, so it's undefined. And then the other two situations would be a positive slope. It just looks like it's going up. And a negative slope would look like it's going down. So when your slope is positive, you should see a ratio that's a positive value, and this one's negative. Which is helpful because when you see a fraction that's negative, you're expecting it to look like this. And when you have a fraction for your slope that's positive, you can expect it to look like this, or vice versa. You're expected to find the slope, you can eliminate all your negative options, and when you have a slope like this, and you're trying to find it, you can eliminate all your positive options. And there you go.